All right, hello guys. We're Alex and Justin, and we just started recording, so you'll be seeing this on the video, and we're just gonna go through a few of the problems from some of those chapter questions, and I also have these kind of answer keys that I've also created, so I'll upload them after we're done this. I don't know if Alex has anything to say as well before we get started.
Oh no.
All right. All right, so I'll pull up and share my screen. All right, so chapter three, we were talking about gains from trade. So there's a couple key concepts I'd say you have to keep in mind when you're thinking about this, and that's obviously opportunity costs, comparative, and absolute advantage. And so when you're going through this kind of cheat sheet, you can look at kind of some of the stuff that I've put in as well, that explains some of those concepts in a little more depth. So I'm going to just go through probably four questions from this one and kind of explain how, I'm sorry about that, how you get those questions or how you get the answers. And then if anybody has any extra questions at the end, I'll kind of answer those as well. Um, so one of the ones that I went over in class that I always kind of like to go over is, so suppose a gardener produces both tomatoes and squash. If he must give up 8 bushels of squash to get 5 bushels of tomato, then his opportunity cost of one bushel of tomato is. And so, like I said yesterday, when you're looking at opportunity costs, it's always going to be what you give up over what you get. So basically, if he's giving up 8 bushels and he's getting 5 bushels of tomatoes, then you're going to use the fraction 8 fifths to get 1.6. So, and what does that mean? That's basically saying that for each bushel of tomato, the gardener is giving up 1.6 bushels of squash. Another way, like I said in class, and I didn't think I, which was kind of the way that I was taught, and I like it, is that say you can either produce 8 bushels of squash in one day or 5 bushels of tomatoes in one day. You can think about, to get just 1 bushel of each, it would take an eighth of a day to make 1 bushel of squash, and it would take a fifth of a day to get 1 bushel of tomatoes. So basically, the way you kind of would be thinking about it is like, within 1/5 of the day, how many bushels of squash would you be giving up? And so you basically get the same fraction, and that's 1.6. So there's two kind of ways you can do it, or you can just think about what you give up over what you get. Um, but that's that one. Now, the other one I kind of went over that I'll just go over quickly is, it says Canada would incur an opportunity cost of 6 units of good X if it has increased its production of good Y by how much? So when you're looking at the PPF of these, you can see that Canada either is going to produce 16 goods, or they're going to produce 8 goods of good X, or 16 goods of good Y. So they can either kind of obtain any sort of a bundle on this line. However, what the question is saying is, when would we incur that opportunity cost of 6 units of good X? So in what case would we be giving up 6 units of good X? And the way you can look at it is, say we only produce 8 goods of good X. If we subtract 6, because that's the opportunity cost that we're incurring, so that's how many goods of good X we're losing, then we would be producing 2 units of good X. And so what amount of good Y does that correspond to on this productions possibility frontier? That would be 12. So your answer for that case would be 12. Um, then another one went over a little bit in class was this one. So assume that Indonesia and India can switch up between producing rice and bananas at a constant rate. And so I always put this one on on the second sheet. And sorry about that. The way that I kind of put it is like right here, where your labor hours and right here was how many units could be produced. I just flipped it around a little bit to where I have rice and bananas on this side and the countries on this side. So Indonesia can produce 20 units of rice or 8 units of banana, and India either 10 units of rice or 20 units of bananas. So you can calculate the opportunity costs by simply what you give up over what you get. So for opportunity cost of rice, uh, if they're getting 8 units of bananas and they're giving up 20 units of rice, then that means the opportunity cost of rice is 2 fifths bananas. And then you can kind of just calculate through the rest of these. So as we can see, we're going to see that Indonesia is going to be the rice producer because they have a lower opportunity, they have a comparative advantage in that. And India is going to be the banana producer because they have a comparative advantage in producing bananas. So Indonesia has the comparative advantage in rice, and India has the comparative advantage in bananas. So in this case, the way that we're going to look at this is we kind of set up an inequality to where Indonesia wouldn't want to produce any less of 2 fifths of an opportunity cost of bananas, and India wouldn't want to trade at a level that's higher than this of an opportunity cost of 2 bananas. So we're going to look at this kind of middle value. And the only answer that corresponded with that was 3 fifths. So if you're kind of thinking about it, it's just basically at an opportunity cost lower of this, of 2 fifths banana. So if it was like 1/5 banana, Indonesia would just say, we're going to stick to producing on our own. And for India, if the opportunity cost was higher than 2 bananas, they would say, we're just going to produce on our own as well. So you're going to kind of look at this middle value right here, and that would be 3 fifths right there. Alex, do you want me to go over one more, or are there any others you would like me to go over as well?
Sorry, I was muted. Honestly, I can kind of start unless someone has any specific question in that chapter.
Yeah, so I just wanted to explain those a little more in depth. And if I don't know, does anybody in chat have any question on here? Or
No,
all right, well, I'll let you just go on.
let's hope my technology works this time. Perfect. Awesome. So I'm gonna now do a little bit chapter 4, supply and demand. I think the first couple on top are pretty self-explanatory. The true and false ones. So I'm gonna go to the number 5. So which of the following is not a determinant of demand? Kind of just have to memorize what influences the demand of a good. So it's obviously future price, which means the price of the good next month would be future price. Then substitutes and complements also can influence the demand. Now let's look at number 6, the first kind of analytical question. The movement from point A to B on the graph shows A, and without even looking at the answer choices, you can kind of see. So firstly, what does A to B represent? It represents a increase in quantity demanded. And it is not an increase in demand. One has to realize that a change in price affects the quantity demanded, not the demand. The demand curve would be a shift. This would be an increase in demand, but not. But when a price changes, that is an increase in quantity demanded. Same with supply. If you have a supply curve drawn here, and the price changes, that's only going to be an increase or decrease in quantity supplied. So number 1A and B, the price decreased. And then when you look at the answer choices, I'm sure one of those is on there. Yeah, increase in demand is wrong, decrease in quantity demand is wrong, increase in quantity demanded is the only and the right answer. So just just for the exam, realize that always when the price of the own good changes, not of the substitute, because if the price of a substitute changes, that will increase or decrease the demand, but not the quantity demanded. Now, figure 4.5, which of the following would cause the demand curve to shift from demand B to demand A? This is a decrease in demand, not in quantity demanded. So which of the following would cause? So we're looking at scenarios that would make the demand B decrease. So that means if the answer choice has something like the price of the own good falls, that would be wrong, following the earlier principle that just that you understand, you know, the difference between demand and quantity demanded. A freeze in Florida. Why is that not the case? Because that would affect the supply. If you want oranges, you don't know what happens in Florida, you'll buy them regardless. Technology advancements, that would also be good. Maybe they would get cheaper, maybe they could produce more, but that wouldn't make you want oranges more or less, just because they're better at making them. A decrease in the price of apples, that's the only one, because that actually is a substitute. So if the substitute price decreases, then people will just be like, yeah, I don't need oranges. If apples are so cheap, let me just save some money. So that's the only one. And the last one would increase the demand. Refer to table 4.3. This 4.3, whom is the price of normal good? Kind of a trick question. It looks like an analytical one, but here you just have to recall that a normal good refers to one's own income, because an inferior good is that if your income rises, you tend to buy less of it. People, econ textbook use ramen as the perfect example. You know, poor college kids eat a lot of ramen, but then once they grow up, there's no more ramen because their income increases. And the normal good is the opposite. It's if your income increases, you buy more of it. But this tells us nothing about the individual's incomes. So that's why D is the answer. Figure 4.20. If the price is 25, then there would be an excess. So how you read those graphs, you can kind of like, we have time now. So let me just demonstrate these. Maybe except for the 25 price, those lines don't really matter. So you can kind of imagine those non-existent. Firstly, they're just there to help you or maybe even confuse you. Who knows? And then you basically look at the price of 25 and you draw a straight line through it here. Bam. So let's mark the demand curve as red. Let's mark the supply curve as blue. I hope I didn't confuse you guys now more. Maybe make this thin. So then you basically look where the demand curve intersects this black price at 25, and then you go, oh, wrong color. And then you go down here at the price of 500, at the quantity of 500, this is the quantity demanded because it refers to the demand curve, because this price at the demand curve is the quantity at this price is 500. And also this price, at this price, there will be 800 of the goods quantity supplied. So basically the difference would be 300, because at a price of 25, companies would sell 800 units of that good, but the demand would not be so high because the price is so high. Let's imagine you sell iced tea, a real world example. If you could sell your iced tea for, let's say, $300 per cup, and people would buy it, then there would be so much supply, then people would be, yeah, let me sell iced tea for such a huge margin, for example. No one would demand it at that margin. So that's why if it's above equilibrium, there will be an excess supply, but a not enough demand, and vice versa. When it's below, there will be more demand than supply. So and the difference is 300. I hope that makes sense to you guys. There's another question that actually is exactly the same, but I'm gonna skip that if the principle is clear with this example. This one is pretty easy. You're just basically asking for the quantity supplied at $4. So you look at the price of 4 and add all of them together because you're asking for the market quantity supplied. So here I still have something written. So just analyze the graph. They're asking you to analyze this panel C. What can you read? So firstly, the quantity demanded, that's important, increases. The supply increases, so supply and quantity demanded, again, distinguish, and the price falls as a result. So if you just can spot those three, you can even test it with all of those three, like at home, be like, oh, what happens here? They didn't even ask you for panel A, but see if you could actually right, price rise it, demand increases, quantity supplied increases. Get the point. This one is again the example with the surplus. Again, at price 16, you would do the same. You would draw here this line. C, that would be the quantity demanded would be 1, quantity supplied would be 4, and that would be a surplus of 3 units. Let me do this one again because I was kind of rushed to do that one. So every chain, so let's start off with the normal supply and demand. So if demand increases, then we know the price will increase and the quantity supplied will increase. So I hope that makes sense. Like that's a given that at the new equilibrium, both these quantities would increase. However, if the quantity demanded and the supply increased, we always have something that is ambiguous. That means either the quantity demanded or supplied and vice versa would change more or less. And basically in this question, they're trying for you to spot this change. So how you solve this question is start off simply by drawing this quantity demanded and quantity supplied, and you mark it. And remember, demand goes down. Remember the letter D, demand down, sloping, and supply up. That always helped me. And mark the graph, quantity and price. And then what are they asking for? A personal computer, suppose an increase in both the supply and demand for personal computers. Furthermore, suppose the supply for personal computers increases more than the demand. So all you have to do in this question is mark those changes, but really exaggerate that supply shift. So let's call this new supply here increases by a lot. This is supply new. So let me also mark the old equilibrium. So this is the price, the initial price, and initially Q. And then the quantity demanded increases, but it increases less. So basically I wouldn't draw it like up here. I would draw it very slightly, just about right here. Do you see this is, and then this becomes the new equilibrium right here. So do you see how, you see how price decreased and quantity demanded increased. However, if we were to say supply increased less, so just to demonstrate they didn't ask that, increased less than demand, then you would still have the quantity increasing, but then the price would actually go up. So that just shows you. So yeah. So equilibrium price to rise, this is always, and the price to be ambiguous. So the answer is equilibrium price to rise and so both would rise. No, equilibrium quantity to rise and the equilibrium price to fall. So 20 should be B. Were there any questions in the chat? Everything clear? All right, chapter 10 then. So chapter 10, I'm gonna just go through it. Chapter 10 is basically pretty much the analytical part of chapter 10 is pretty much 3 formulas. And I'm gonna really go into detail about that long one, you might remember from class. And just explain that, because if you can solve that one, like I said, all other questions will be a breeze. The first one uses this formula, this GDP deflator. You just need to kind of memorize it. I don't know how she is, if she lets you guys use a note card or not. I think she does. So, or just write it down and know how to plug in the values. So the first one is GDP deflator, plug in the nominal and you plug in the real GDP. And then you get 96.1, and because that's less than 100, the prices are low. Nothing more to that. A simple algebra. This one is the formula for the GDP. So all you're doing is you're solving for one unknown here, and you're plugging all of this information in this formula. And that's really an important formula, and you will see this throughout this whole semester. So I would recommend you guys kind of already learning it. The Y equals consumption plus investment plus NX, which is exports minus imports, and X, and plus government purchases, because the later chapters will really utilize this formula like a lot. So good idea to just kind of memorize it so far, and then it's going to become kind of important. Now let me go through this kind of long one. I know last year a lot of people complained about this one, but it's not too bad. I hope you see it. For some reason this 100 isn't showing, but so you're asked to kind of solve this country's inflation rate just based off this table. And the way you solve it in the exam, you might be like, how do I do that? Because it just seems like we don't have enough information. You would start by saying, what's the inflation rate? The inflation rate is the GDP deflator minus the GDP deflator in the year before, divided by that times 100. It's the inflation rate. And then you're like, okay, well, what's the GDP deflator? Well, in 2016, it's just nominal divided by real times 100, like we used in this in the first question. And then for 2017, it's the same. So then you're like, what's the GDP nominal and real GDP? Well, this is just price times year times quantity of the year is the nominal, and then real GDP is price times base year times quantity of the year. So I kind of drew this in, and I kept the color theme that you don't get confused. So nominal GDP is 880 because it's 4 times 120 plus 2 times 200, and then real GDP should be the green here. And yeah, once you do this the same with both years, kind of just changing, the quantity this to 150, but the calculations are pretty much the same, and changing the price of the nominal GDP, and then you plug those back into this inflation rate formula up here, and you should be able to solve this. Actually isn't too bad. So and then you get a 23.1. It's definitely a long one, and I wonder if she's going to bring something like that in the exam, but it's good if you guys can kind of try to solve this on your own. And if you guys actually get the right answer, then you definitely understood all the 3 formulas and how to kind of utilize them. This one, honestly, I'm not gonna even go over it. This is really easy compared to the last one. It's just, again, these same formulas, calculating the nominal and real GDP. The country output growth is basically like a percent change formula, just that you use real GDP minus real GDP in the later year minus earlier year times 100. It's the same again with the price times quantity of the base year, and always mark the base year. Yeah, and this is honestly again the same formula. I could do the same problem over and over again. Just here, the base year is 2015 in this one, so that's why I marked it over. And it's not always the last year. Like, don't always think the earliest year of the problem is going to be the base year and blindly start using 2014. Always look what the base year is and underline it. But it's usually this number. But this question kind of shows you, oh, we can switch it up if we want. And yeah, that's pretty much it. So it's just you need those formulas, and you don't even need to like memorize them. If you guys can use note cards and just know how to kind of solve them and even combine the formulas, like in this example down here, and then you should be good to go. Are there any questions?
Any questions in the chat? All right, well, if that's the case, then I'll just quickly go over chapter 11. Quite frankly, if you know how to do the GDP chapter, then this chapter is, I mean, very similar.
You mean chapter 10? Yeah.
Yeah.
And it definitely help.
Yeah, because this is all about a CPI index. So yeah, so I'm just gonna go over this. Sorry about that. Just real quick. So a few that I'll go over is basically, I think one of the biggest things to denote is just how to compute CPI. And Dr. Manal Langston talked a little bit about that in her class. So I have this kind of equation up here. I should have written CPI right there, but it's basically just CPI is going to be the cost of the market basket in a given year. So the determined market basket, what is the cost of that over what is the cost of that market basket in the base year, which kind of gives you that index of price. And then, you multiply it by 100, and that allows you to get, your total CPI. And if you kind of think about it, what I always like to tell people is just the CPI in the base year is always going to be 100, because if you're dividing the cost of the market basket in a given year, and if that is the base year, then this would basically just be the cost of the market basket in the base year, which is the given year, divided by the base year. And then once you multiply that by 100, you get 100. So, and the reason why the CPI is good is because it helps us give the inflation rate. So if we have some sort of market basket indexed for price, we can kind of use, because if you look, this inflation rate is nothing different than just a percentage change formula, just like Alex explained in the GDP deflator chapter. Is it's basically going to be the new CPI minus the original CPI, and then divided by that CPI times 100, and that'll get us the inflation rate, or how much prices have increased between two given time periods. So I think that makes very much sense. And then if you kind of have that, concept down, then a lot of these multiple choice questions, quite frankly, really make sense. Um, so the inflation rate, I'll talk a little bit about this one. So computing, excuse me, I'm talking about the real interest rate here. So computing the real interest rate, she talked about this in class. It's simply going to be the nominal interest rate minus the rate of inflation. Now, there is another equation that you probably may have seen, and that's this 1 plus the nominal interest rate divided by 1 plus the inflation rate minus 1, and then you multiply that by 100. Just make sure you put parentheses around that. But regardless of that, it's really simple. It's just real interest rate is equal to nominal minus inflation. So as you see, like I did the same thing right here, and you should end up getting 5%. So just 8 minus 3 is going to be equal to 5. And if you know that if you know that the real interest rate is equal to the nominal interest rate minus the inflation rate, then you can kind of flip that equation around a little bit algebraically to, get the inflation rate or to get the nominal interest rate if you know either of those other two variables. So that's that. I'll go over this one real quick. The table below pertains to Iowan, an economy in which the typical consumer's basket contains 4 pounds of pork and 3 pounds of bushels. So they want to ask, what is the CPI if the base year is 2013? So this one's a little bit different in that we're using 2013 as the base year. So if we know that there's 4 pounds of pork, remember you always multiply quantity by the price. So if we're looking at 2013 being the base year, we're going to multiply 25 times 4 and then 18 times 3. And when we add those up, that'll get us the excuse me, the cost of the market basket in the base year. And then we're going to use these prices right here to get the cost of the market basket and the year that we're trying to figure out the CPI for. So we're going to do 20 times the same quantity and 12 times the same quantity for corn. And so when you do that, 20 times 4 plus 12 times 3, you're going to get 116 divided by 154. And that'll get you some, I think like 0.7532. And then when you multiply that by 100, that gets you the CPI. So it's very similar to the GDP deflator. The GDP deflator was using nominal and real GDP, but in the essence of, just, following out this formula, multiplying by 100. And so that's how you're going to get the CPI for if they ask for 2012 and the base year is 2013. So sometimes they might flip it around on you a little bit. And as we can see, prices in 2012 were lower than the base year because since that 75 is less than 100, that denotes to us that prices are lower in the base year. Now, if it was greater than 100, then prices would be greater than the base year. And then it's 100, then prices are the same. And then the cost of the basket in 2012, well, we kind of already calculated that. So that was 116. And now this one, if the base year was 2012, then the CPI was for 2013 was, and I mean, you could flip that around, or you could kind of just do it where, if you want to just work it out, if the base year is 2012, so that's going to go up on the bottom. So 20 times 4 plus 12 times 3, 116, and then 154 when you do it for 2013. And then the last part of this question would ask you if 2012 was the base year, then the inflation rate in 2013 is what? So basically, we know that the base year is going to be 100. So if we're trying to figure out that percentage change, then we're going to use this CPI value right here, which is 132.75, or roughly 132.8, either one you want to use. And then since we're comparing that with the base year of 2012, which was 100, it's just going to be 132.8 minus 100 divided by 100, and that gets you 0.328. Multiply that by 100 to get the percentage form, and that would be 32.8%. Now, and the last one I think I'll cover is this one, because this is a little bit of a tricky question that I think stumps people. So the question's asking, Ruben earned a salary of $60,000 in 2001 and 80,000 in 2006. So the consumer price index in 2001 was 177 and it was 221.25 in 2006. So what's Ruben's salary, 2006 salary? So what's this salary in terms of 2001 dollars? So basically, if you think about it kind of like a time machine, we're taking this salary and we're trying to convert that back into 2001 to see how much money was he making in 2001. So that would give us an estimate of is he making more now than he was back then. So the way that I kind of figured this out was I basically, figured out what was kind of the inflation rate. So basically the inflation rate from those years was, we're going to take 221.25 minus 177 and then divided by 177. So that's going to get you 0.25. Now, since we know that that means that prices have increased by 0.25, we kind of have to we basically have to take this 80,000 value and kind of reduce it by 25%. And so that's where I got this 80,000 divided by 1.25. And that basically, what was I going to say? It would be the same as if I kind of did 80,000 times 0.25 and then subtracted 80,000 from that. But regardless, your answer or you can do it that way as well, dividing by the CPI. Your answer is going to be 64,000 when you leave it like that. So, and then the rest are pretty self-explanatory. It's not anything that I kind of didn't already explain. So I hope that answers or clears up any confusion for you guys. I'll stop sharing, and I guess right now I can ask the three people that are here. Are there uh, are there any questions? I guess, and Alex and I are free to answer any questions while we're here right now.